Well, hi everyone. I wanted to just kind of go over number 90 here with you. The concentration C of a chemical in the bloodstream T hours after injection. This is page 323, by the way. I'll start over here. The concentration C of a chemical in the bloodstream T hours after injection into muscle tissue is given by C equals 3T squared plus T over T cubed plus 50, where T is greater than 0. Determine the horizontal asymptote of the graph of the function and interpret its meaning in the context of the problem. Okay, so the horizontal asymptote, we have n, this is n is less than m, so that means y equals 0, or in this case, c equals 0 is the horizontal asymptote. Now, its meaning, so it means we're going to approach 0. We're going to approach 0. So the medication, I'm just trying to think of the right, goes to 0. It'll eventually, it goes to 0. The medication will eventually dissipate. Okay? So it's high, and at some point it gets used up. Maybe not completely, but such a negligible trace. All right, now B, it says use the graphing utility to graph the function. So I don't have this in here. I got a bunch of stuff in here. Let's just get everything else out of here. I need to use parentheses on this. So the numerator is 3t squared. So let's go 3x squared plus x. And close that. Get this at a better, the light's not shining on it. And then divide that by the denominator, which is x cubed, plus 50. Okay, right now, and it says when t is greater than 0, so I might change the, I'm just going to graph it. This stuff is not part of it. Okay, so what I'm going to try to do here, and we're looking at small numbers, it's doing something over here. I'm going to go with the window, I'm going to change this to 0, and I'll go 0 with the men, so I'm looking in the first quadrant. I'm just going to go up to 1, because yeah, I can see that a lot better when I do that. So I went up to 1 by changing the window. It says use the graphing utility to graph the function, determine the approximate time when the bloodstream concentration, this is C, so up here, when it's its greatest. So I'm going to see if we can get a max here. So I'm going to go second calc and go maximum, left bound here, and then right bound here, hit enter. Okay, max. So use the graph to approximate the time when the blood concentration, so that's the x. So I would go in about 4.5 hours. About 4.5 hours. I see the 4.486 there. So 4.5 hours. And then C is use the graphing utility to determine when the concentration is less than 3.45. Okay, so well, here's what I'm going to do. I'm going to put in y equals, it's not 3.45, it's 0.345. Hit that graph. All right, I see two places where it's crossing. And there is on the calc, I don't know if we've ever done this, but we can use intersect. And I'm going to go below the vertical here. That's not vertical, the horizontal here. Hit enter. and then that's my first curve, and the second curve is the horizontal line, and hit enter one more time. It tells me the point of intersection. So when t is greater than 0 and less than 2.64 hours, it is, but it's also, so from here to here it's less, and from here to here it's less. So let me do intersect again. Intersect. I'm just coming over to this side here, closer to this point, because there's two places where it intersects. And second curve, enter. I'm getting t is greater than 8.3 hours. All right, so before 2.64 hours, the concentration is below 0.345, and after 8.3 hours, it's less than 0.345. All right, there we go. Thank you, guys. Bye.